Okay, well, hopefully we don't run out of electricity in the battery on the camera. All right. So, oh, damn it. I got my tea. All right, so let's open, do you know what page the problems are on? Review questions for...
No.
All right, the short answer is 44. The long answer is, I'm not going to tell you. Yeah, here you are already. Okay, what's the particular problem?
Was two.
Was 2?
Oops. Yeah, two, the second one, 2.3. Yeah, 2.3.
Okay, well, that's,
Am I using the formula? Which one was it?
all right, well, one thing that I did
7,
this morning,
6.
you're saying 7, and I don't know which one that is.
No, the examples on the formula.
What I did was I actually sat down with Word and put all the formulas from chapters 2 and 3 into
Oh,
a cheat sheet. Damn it, you can't share this in reverse. I can share the computer screen, but I can't share what I'm showing here on the overhead. All right. All right, well, always the first thing to do, so it's problem 2.3. We write down what we're given. All right, so we have product A and product B. All right. Our production Q for A is 3,000 units. For B is 2,000 units. The number of components for A is 25%, 25, not 25%, and for B is 36. So far, so well. All right. So our made in plant percentage for A is 40%. And 60% are purchase parts. And B is 30%. All right, so purchased would be 60% and 70%. Okay. How exciting. So we want to know how many components are made in the plant and how many are purchased. All right, so total components made in plant. Well, the Well, I mean, we could do this as one giant calculation or a couple of little ones and add everything up. And it'll be the same either way. But let's think about it for this part of the problem. We'll think about figuring it out we'll figure it out one component at a time. So product A parts, and I'm going to put MIP for made in plant as my subscript. All right, so we know the total number of production Q, and we know the number of parts, so it's going to be Q times NP. I should say QA and NPA to make it totally clear. And then we're just going to multiply that by percentage made in plant. Right? Do you see my logic there? She's being ominously quiet. Now I'm worried.
Yeah.
Oh. Okay. Right. So QA is the number of products Q that we make of A. NPA is the number of parts needed for A's. And then percentage made in plant. All right, so if we just multiply those together, so that's gonna be 3,000 times 25 times
30,000?
is gonna be 100, 300,000, 75,000 times 0.4.
30,000.
Okay, I'm hoping you're doing that on the calculator because my math isn't going as fast in my head as I thought it
Yeah,
would.
30,000.
All right. All right, so that is our number of parts for A made in plant. All right, now we're just going to apply the same logic for product B.
It'll be 21,600.
Of course, I hadn't anticipated you doing it so quickly. All right, so there's number of parts for B made in plant. 21,600, you say?
Yes.
All right, so that means that the number of parts made in plant is going to be 51,600 units.
And then you would do the same thing, multiply by that 70% for the other part.
Right, exactly. So for total components purchased, we would do the same thing. That's going to be equal to the quantity A, the quantity of parts for A, the percentage purchased, plus the quantity of B times the number of parts in B times the percentage purchased. As the old educational gag goes, we leave the rest of the calculation for the student.
Oh, and then you just add them together, so that would be what, 95,400 units?
Got me, I haven't worked it out.
95,400 units.
Fantastic. Now, here's the problem that I think you're having, is that they don't always describe everything the same way in the formulas and the slideshow as they do in the book and the problems.
Yeah, I was trying to figure out which formula I was supposed to use for that. That's what I was having problems with. Trying to figure it out.
Okay, so I should pull up the homework sheet for this class. Oh, that's not the homework sheet. There we go. 2325. Well, damn it, that's gonna work out. Let's go ahead and do 2-4 while we're in the vicinity. It has the virtue of not being on the homework list, and the answer's in the back of the book. Now these, for some reason, these more modern books, they they only do the answers to a few problems. I'm used to the old-fashioned way where every odd-numbered problem, they have the answer at the back. All right, so we always start by writing down what's given. All right, so we've got two models.
X and Y.
Model X and Model Y. My Y didn't come out very
Why?
good. Because apparently my hand was fighting me. All right, so the number of components for Model X is 4, and they are A, B, C, and D. All right, and the number of operations are 2, 3, 4, and 5. All right. Model Y has 3 components, E, F, and G. And the number of processing operations are 6, 7, and 8. All right, so quantity for A is, for X, excuse me, is 1,000 and quantity for Y is 1,500. All right, so first it says, oh, I thought it was gonna be harder than that. First they say, what is the number of components? All right, so A, number of components. All right, and that number of components is NPF. All right, so I'm going to do NPF X, which is going to be equal to the quantity X times the number of parts X times the well, P doesn't enter into it because we're only doing one at a time. So that's 1,000 times 4 components. All right, I don't want to say this is like kind of an easy calculation. All right, number of parts final for Y is QY times NPY equals 1,500 times 3. So 4,500. All right, easy peasy. So put them together, and what have you got? Bibbidi bobbidi boo, as the old song reminds us. So 4,000 plus 4,500 is obviously 8,500. All right. Now, the total number of operations is a bit more exciting, because then that is going to be our NOF is going to be the quantity of X times number of parts X times number of operations X plus the quantity of Y, number of parts Y, times number of operations Y. Now, I'm really feeling like they've left out that it should be a summation of number of parts times number of operations. But you know what? We'll do it their way and see if it works out. All right, so quantity of X is 1,000. The number of parts is 4 times 14 operations plus quantity of Y is 1,500 times 3 parts times 21 operations. All right, so I make that 56,000 for X plus 4,500, 90,000, 94,500. Feel free to correct me here. Uh, 150,500?
Yes.
I'll just do a quick.
Yep.
All right, come on. Where's the answers? Come on, guys. All right, they're saying 45,500 operations. All right. All right, so let's try saying that the quantity of X is 1,000, parenthesis, and two plus 3 plus 4 plus 5 probably 14, but 1,500 times 21. 30,000. $31,500.
So it looks like they multiplied the units times the number of operations. So the first one, you would get the 14,000. If you add that to the 1,500 times the 21, you get the, what is it? 31,500. And then if you add them together, you get that 45,500.
All right, which seems to expose that the formula that they gave us here should not have the number of parts in it. Do you see what I'm saying?
Yeah.
I'm so disappointed. Right, the uppercase P is correct, because what we really did was we just separated into two pieces, right? Because that's supposed to be the total number of parts. All right, damn it, I want my Excel. I hate it when we have engineering with shaky math. All right, so if we average that, it'd be 1250. And if we average the number of operations, it would be, oh, bloody hell. 21 plus 14 divided by 2. See, that comes out with a really wonky number. All right, so do they have the number, the formula rather, in the book the same way they have it in the slideshow? Okay, I have no idea who this is. Hello?
Your life,
Yes, it is.
this is Brooklyn. Are you on campus today?
Yes, ma'am. I'm teaching class right now. The whole class is listening to you, so don't say anything embarrassing.
I have a couple of items I need to, and I wanted to send the
That would be perfect. Thank you. I will come by in a bit and get all of that. Okay? Thank you. All right. Oh, okay. Don't hold anymore. All right, there we are. We're back. And we're badder than ever. Ba-ba-ba-bum. Okay. equals 2,500 times, let's see, would be 35. Still wrong. Oh, okay, I see. In the book, it has a different, on page 40, it has a different way of calculating it, where it's summation within summation, which essentially is what we ended up doing. Essentially what we ended up, oh, I need to go wider. Which is essentially what we ended up doing here. So. Well, you know, that just sucks. That I'm gonna have to go back and redo my cheat sheet. All right. Despite the let's go over here to the end of chapter 3 and we'll do a few example problems. Now, I'm asking myself, should I leave the problems with answers for homework? And I'm going to say, yes, I should, even though I'm very afraid to do that. So that means we're zooming out on our own.
Oh, man.
All right, so what we got? Let's try problem 3.2. Can you see where I'm writing?
Yes.
Okay. Well, with this little thing, man, you get all wonky and
Oh,
and then I'm writing someplace and the students are saying, we don't see anything. Grouchy students. All right, so this is cycle time and production rate. In a sequential batch machining operation, setup time is 1.5 hours and batch size is 120 minutes. 120 minutes? Units, excuse me. Well, it ends in its anyway. All right, so we're given that
Setup time?
our time of setup equals 1.5 hours, man. These better be pretty giant-sized things. And our number in a batch is 120. Gentlemen, how may I help you?
Hi, my name is Camille.
Oh, yes.
Is there any office here for him?
Yes, there it is. Get it.
Get it right away.
This one?
Thank
Yes,
you.
that's the one.
Just chairs. I have seen this one this morning, but.
Well, he gets to sit down anyway. I'm sorry, Kamel, that's the only space we got, man. Now, I suggest though that you steal Dr. Roman's space and make him go in there.
Okay, okay. I
Uh,
have another option, so I'm going to show him first and then he will decide.
Okay, go ahead and do that.
Thank you, thank you.
Thank you.
So happy to help, of course.
Thank you so much, Harry.
Cycle time. Oh, okay, so part handling is 30 seconds. Time of processing, 2.85 minutes. And one part is produced each cycle. Tool change time is 2 minutes each 10 parts. Man, this had better be a damn expensive part.
Oh, 2 minutes at 10 parts. I guess I could have used that little extra piece I ripped off.
That little extra piece at the top.
No, that I ripped off.
That does seem to have shorted you some paper.
Okay, let's see, batch size, so it's been, for your 120, what is that in, what did you use for that? Was it BS?
No, it's NB
Oh, just
for
NB.
120.
Okay, for number of batches, okay.
The number in a batch, yes. All right. So,
And we are determine average cycle time, time of production, after production.
all right, so we know that the first thing we have to figure is our cycle time, which is TC equals TO plus TH plus TT.
TM plus TH plus TT. Okay, so it's figure 3 1.
All right, and that's of course where TC is cycle time, TO is operation time, TH is handling time, and TT is tool handling time. Now, one thing that we've got here that makes it difficult is you'll notice we got 3 different time units going on. We got hours for the time of setup, we got seconds for the time of handling, and we got minutes for operation time. Okay, so we have to be aware and put everything in the same time period.
So you'd have to convert everything to seconds.
We could convert everything to seconds. I was actually gonna convert everything to minutes, because I don't know, I can't remember off the top of my head, I used to know this, what 0.85 of a minute is in seconds. But if you tell me, of course, that would help a lot. All right, so cycle time, the time of operation is gonna be 2.85 times, right, that's minutes, so times 60 seconds per minute, plus time of handling is already 30 seconds. Plus, now, this is gonna be cycle time per part, right? So it's gonna be, it's 2 minutes every 10 parts. So that means there's gotta be 12 different, so it's gonna be 2 minutes times 60 seconds per minute. It's gonna have to be changed 12 times, but it's also that total time has to be divided by 120, right? Because we need, put my parenthesis in the wrong place. Right, because we've got to get it down to what that is stretched out over the whole thing. Right, so I can knock off, I can take the 12 out here and change this to 10. All right, so 2.2, oh no, 3.2, 3.2, so he told me a terrible story, but it doesn't diminish my glory. All right, so equals 2.85 times 60 plus 30 plus 2 times 60
Oh, that's plus
divided by 10. All right, so what are you getting?
$213.
I was hoping you would say that. All right, that's also what I got. All right, so now we've got our cycle time. And all right, so that is A. So that's our average cycle time. Although if these are pure numbers, I would bet on our average being a little more, but it's a textbook problem. So our batch time is going to be TB equals time of setup
TC?
plus Q times TC. I'm sorry?
Oh, Q times TC, okay. I was looking at the wrong one. So it's TB equals time of setup plus QB times TC.
All right, well, our time of setup is 1.5 hours. We know that there are 3,600 seconds in an hour. Plus, we know our quantity of batch is 120 times our 213 seconds. All right, and just to get a handle on the situation, I am also going to go ahead and convert that into hours and minutes. Because if you say it's 30,960 seconds, people may not understand what that implies. For that matter, I just knew it was a big number myself. All right, and we want to know the average production rate. All right. All right, so our average production rate, or is time of production is equal to TB divided by Q or rather our average production time. So our 30,960 seconds by 120 units. Uh-oh. See what I mean about not moving the head? All right, so equals so that is seconds per unit. And to get the production rate, it's equal to 1 divided by um, 1 divided by TP and that's in units per second, obviously. Okay. Well, we're really tearing up the countryside. Um, with that one. Okay, shall we do another? Man, we are not going as fast as I expected, but hopefully we're learning a lot. Should we do another cycle time and production rate, or should we move on to another section?
Another section.
Okay. Yeah, it looks to me like this next Wednesday, we're also going to be doing. All right. Workload and production capacity. I mean, feel free to shout out a number here in the meeting. Let's start with problem 3A. And depending on how well that goes, we can come back. All right. What are we given? All right, so we have type A, type B, type C, oh, and type D, my God. We got types out the wazoo. All right, so this is for a week. All right, so we got 540 A's. 1,200 Bs, 490 Cs, and 780 Ds. All right, so time of production, .28 minutes for A, 2.86 for B, 4.65 for C, 3.22 for D. All right, so we want to figure out the workload for this shop in a week. All right. Well, workload is equal to the quantity times time of production. And this is starting to sound pretty simple when we say that, because we're going to say workload equals Q of A, QPA, plus Q of B times QPB, plus Q of C times T of PC, plus Q of D, T of PD. All right. Or 540 times 5.28 plus 1,200 times 2.86 plus 490 times 4.65 plus 780 times 3.22. All right, well, easy squeezy, easy peasy, lemon squeezy. Equals 40 times 5.28 plus 1,200 times 2.86 plus 490 times 3.65 plus 780 times 3.22. All right, and that is in minutes. All right, equals okay, 184.555 hours. 11,073.3 minutes. Is that what you're getting, or?
Hold on.
Take your time, there's no
11
broken leg pain.
Did you say 11,073.3 hours?
Minutes,
I mean, yeah.
right. Then I divided through by 60 to get the number of hours.
Oh, by the number of hours. 8,603.56? Did you say divided by,
Divided by 60.
oh, yeah.
Yeah, 8,000 seems high, unless there's only a minute and a half per hour.
What did you get?
I got 184.555.
Oh, yeah, I'm sorry. 184.555, yeah.
Right, right, okay. Phew. Thank God we're on the same page.
Oh.
Okay, well, we ran through that problem faster than I thought we would. Let's take a quick swing at 310. Okay, so I'm not sure how to interpret this. It says 1/500,000 parts of a certain type are to be manufactured annually on a dedicated production machines that run 16 hours per day, 5 days a week, 50 weeks per year. The cycle time to produce one part is 1.8 minutes. If availability and utilization are each 100%, and setup time is neglected, how many machines are required to satisfy demand? Well, actually, that shakes down to a simpler problem than I thought at first. All right, so problem 3.10. Also a workload problem. All right, so given our number of parts, I'm going to call 500,000, despite the weird. Our time of production, 1.8 minutes. Oh, I'm looking for one, no wonder. Or excuse me, cycle time is 1.8 minutes. All right. Our factory runs 16 hours a day, 5 days a week, 50 weeks a year. And they want to know how many machines. All right, so our Well, first I would say, let's calculate time available. All right, so because our cycle time is in minutes, let's go 60 minutes per hour times 16 hours per day times 5 days per week times 50 weeks per year. All right, so that is going to give us our minutes per year. All right. So, equals 60 times 16 times 5 times 50. $240,000 minutes per year. The number of machines I want a more compact work area. All right, so 240,000 minutes per year. Do you see a flaw in my calculation?
Your hours in a day? Oh, wait, maybe I should read it again, so, oh, no, 16 hours a day, 5 days a week.
All right. All right, if that is the number of minutes in a year, then we are going to want to divide number of machines well, they actually have a formula here: plant capacity for the week, hours per week, S is number of production machines, we could let me see, if we divide through our time available by the number of units, then we have minutes per unit, and that becomes the takt time. But if we turn it upside down, then it becomes units per minute isn't that our production rate? Yes, I'm gonna say it's units per minute, so, so our number of machines is gonna equal our quantity divided by time available. That's units per year over minutes per year. Years are lost, it's units per minute. So I'm calling that 3 machines. So equals 500,000 divided by and that's units per minute. Now, if they put the wrong symbol in, and it's 1.5 million, then it's gonna be 7 machines. Death, where's thy sting? I'm out of tea. Okay, so if it's 2.083, why am I saying it's 3 machines?
Because you need more than the 2 machines to actually complete it. You're gonna need to resort to the 3rd machine.
I think what you're saying is we can't have 0.083 of a machine.
Sounds good.
Okay, that's all our class time today. So I will go ahead and, are there any questions? As I said, we're gonna have to pick this up on Wednesday, and do more problems then. Okay, Mr. Lee, I don't know if you're listening, but carry on. Uh-oh, he started to say something just when I was pushing the hang up button.
Do you got the, or do we have a homework assignment?
Let's do the homework assignment Wednesday after
Class, okay.
we've done the problems.
Okay.